Hello, my amazing students. This is Mrs. A, and I love math. Today we're doing lesson 80 in our Saxon Orange Book, and we are talking about operations with scientific notation. But before we start, I want to give a shout out to a young lady named Hope, who is now in the half algebra and will someday be listening to me in algebra. So she contacted me and told me that she enjoyed my algebra half videos. So if you have a younger brother or sister, there's some videos out there for the Saxon Blue Book, the algebra half. And I know someday she will be in this book. So I wanted to say, hi Hope, thanks for the email that you gave me. I really enjoy teaching you. And of course, I always want to shout out to Hannah, who is my granddaughter, who is the one that I'm making this video series for. I started it for Michael, but he was faster at it than I was, and he got through his algebra without me. And so now Hannah, who's next in line, is benefiting from the videos. I hope you are too. So let's start with scientific notation and operations with scientific notation. So here we have two numbers, and this one, remember when we're counting, this would be the thousands place, and then this one is the millions place. Okay, so 4 million, and then down here we have 20 million. That's a lot. So the nice thing about scientific notation is that it helps us with things like multiplication and division, because it's very difficult to keep track of all those zeros. Okay, hopefully that's a little less clear on my board. So when we're talking about 4 million, how do we write that as a scientific notation? So remember, it's going to be 4 times, because the number in front of the scientific notation must be between, it can be 1 all the way up to 9, but it can't be a 10. Okay, so 4 times. Now we've got to represent how many times we need to move a decimal that's right after the 4 over. So 1, 2, 3, 4, 5, 6 times. So that's going to be 10 to the 6th power. Okay, and then we're going to do the same thing for 20, but the first number on 20 will be 2. Okay, so then the decimal would be right there, and then we're going to show moving it 7 places to the right. 1, 2, 3, 4, 5, 6, 7 to get to the end. So 2 times 10 to the 7th is 20,000. So now that we've represented them each in scientific notation, now we're going to multiply the two together. So we have 4 times 10 to the 6th times 2 times 10 to the 7th. Okay, and we are going to multiply them together. So I'm going to multiply these together first and get 8. 4 times 2 is 8 times 10 to the what? Now remember, when we multiply, we have exponents we add. So we multiply like bases. They're both the base of 10. Multiplying like bases, I add the exponents. 7 plus 6 is 13. So 8 times 10 to the 13. Now the last thing we would do would be to adjust if necessary. If this number all of a sudden when we multiplied got bigger than 1 digit, then we would have to adjust, and we'll have some that we're going to have to adjust a little bit later. But this one is finished and this one is correct. So that is example 1. Okay, so on this one we're going to multiply a very, very small number times a very, very big number. Now the problem is this one right here is not even in scientific notation yet. So the first step is to get both of these in scientific notation. This one already is in scientific notation because it has a digit in the front that is in between 1 and 9. Inclusive. So here we have to move this decimal right 1, 2, 3 steps this way. So when we do that, we're going to get if we move this 3 to the right, we have to move this 3 to the left. So we would have 3 times 10 to the negative 7 is the same number as 0.003 times 10 to the negative 4. So now we have both numbers in scientific notation. One's very, very small and one's very, very large. Okay, so we're going to be able to multiply them together without having to worry about counting all those zeros. So here we go. 3 times 2 is 6 times 10, and then we're going to raise the 10 to the sum of 20 and negative 7. So 20 minus 7 is 13. So 6 times 10 to the 13, and again, we need no adjustment because this number is in between 1 and 9 inclusive. So it's okay, and we don't need to make any adjustment with that one. Okay, our next example is what happens when we have 0.00004 times 10 to the negative 5 times 700,000. Well, this one is not in scientific notation because this number in the front is not between 1 and 9 inclusive. This looks like scientific notation, but it can't be right because this one's not right. This is in standard notation. So we have two things to adjust here. Okay, on the first one, we need to have the decimal right after the 4. So how many places do we have to move to get the decimal right after the 4? 1, 2, 3, 4, 5. So what we're going to do, oops, I got to take my marker lid off. It's stuck. There we go. We're going to move the decimal 1, 2, 3, 4, 5 places. And because we moved it 5 to the right, we must move this one 5 to the left to compensate for that. So we're going to have 4 times 10, and this moved 5 more to the left will be 10 to the negative 5 times 10 to the negative 5, which will be 10 to the negative 10. Okay, so we moved this 5 places to the left to compensate for the fact that we moved this 5 places to the right. So we multiplied by 10 to the 5th, and then we divided by 10 to the 5th, which is the same as multiplying by 10 to the negative 5th. All right, so now this one. Let's get this one into the correct form. We need to move the decimal from here. Anytime you don't see a decimal, isn't it right at the end of the number? So now we're going to move it 1, 2, 3, 4, 5 places to get it right after the 7. So 7 times 10, we know it was 5 spaces, 1, 2, 3, 4, 5, but we moved this to the left. Therefore, we need to move this to the right, so it'll be a positive 5. Now, we stop to check. This one was a very, very, very tiny number. It's still a very, very tiny number. It's just that this is holding all of those tiny number indications, right? And then this one is a really big number, and when we have a positive exponent on the end, it's a really big number. So now we're ready to combine these. So we're going to multiply these together. Now we're going to have an adjustment because when I multiply 4 times 7 together, I get 28, which is greater than 9. Okay, so 28 times 10, and remember when I multiply like bases, I add their exponents. Negative 10 plus 5 is negative 5. Now I have to adjust. This decimal is right here. I need to move it 1 to the left so that this number here is between 1 and 9 inclusive. Okay, so it's going to be 1 to the left, which means this must go 1 to the right. So I'm going to add 1 to this one. So 2.8 times 10 to the negative 4. And there is our answer. 2.8 times 10 to the negative 4. Now, what's going to happen when we divide our big numbers? Okay, so we have to learn how to divide just like multiply. Now, we know that when we divide numbers with exponents, we subtract the exponents, just like when we multiply like bases. We add when we subtract, when we divide like bases, we subtract their exponents. So that's going to make this very, very easy, isn't it? Now, this is the same problem that we had at the beginning, except we were multiplying them together. So let's recall what our two scientific notation numbers were. So here we have to move this 1, 2, 3, 4, 5, 6, 7 spots. So this was 2 times 10 to the 7. Since I had to move it 7 to the left to get it in the right spot, then I have to move this one 7 to the right. So now that big number is divided by this number, and here's the decimal, so we're going to move it 1, 2, 3, 4, 5, 6 places till we get it right behind the 4. So that is going to be 4 times 10 to the 6. So now when we're dividing, we have 2 divided by 4. Well, that's not very convenient. 2 divided by 4, though, is the same as 1 divided by 2, which is 1/2. We don't want to write 1/2. We want to write 0.5. Now, this is in the no-no zone, isn't it? It is out of the accurate way to represent a scientific notation, but we're going to leave it alone, and then we're going to adjust it. Times 10 to the 7 divided by 10 to the 6 is 7 minus 6, 1, 10 to the 1. Okay, now 10 to the 1 is just 10. So guess what happens? This is not in scientific notation, but when we move it into scientific notation, it's going to be simply the number, what? Move this 1 to the right, move this 1 to the left, 10 to the 0 is 1. 5 times 1 is 5. So the answer, 20,000 divided by 4,000, is 5. We probably knew that before we did all of that work, but we're talking about scientific notation, and it was a good example. Okay, so here we have another division problem. Neither one is in scientific notation. So we need to move the decimal 1, 2, 3 places to the right, which means our exponent on the 10 is going to be 3 places to the left. So this is going to be 1.6, which is between 1 and 9 inclusive, isn't it? And now we're going to look down here. 1, 2, 3, 4, 5. So that's going to be 4 times 10 to the 5th. Now we've got a little bitty tiny number divided by a big number, but that's not going to be a problem with scientific notation. So we're going to divide 1.6 divided by 4. So 1.6 divided by 4. Okay, I know I'm going to put my decimal there. 4 into, so once I put the decimal there, I can ignore the decimal. 4 into 16 is 4, isn't it? So isn't 1.6 divided by 4 equal to 0.4 times 10 to the negative 3 divided by 10 to the 5. So division of like bases, I subtract the exponents. So what is negative 3 minus 5? That's a negative 8, isn't it? So we're going to have 10 to the negative 8. Now we look at this. Is that our final answer, or is that not in scientific notation? Look at this. I have a 0.4 instead of a 4. This number should always be greater than or equal to 1, right? So that's not right yet. We're going to have to move this decimal 1 place here and move this exponent 1 place backwards. So that's going to be negative 8 minus 1 is negative 9. So 4 times 10 to the negative 9 will be our final answer to that division problem. All right, so here we are. Okay, so now we're doing multiplication and division at the same time. Now, the rules are going to be the same, but we're going to do everything in the numerator, and then we're going to do everything in the denominator and figure that out, and then we'll divide the two. Now, the first thing we have to do is put all of this in scientific notation. So this one right here needs to come 2 steps to the right. So we're going to put a little line here to keep them straight. 6 times. Now, if this goes 2 to the right, doesn't this exponent need to move 2 to the left on the number line? So 5 take away 2 is 3. So that's going to be 10 to the third. Okay, and then 300,000. This is going to move to right here. So it's right here right now. So 1, 2, 3, 4, 5 steps left to get the 3 that we want, which means we need to multiply by 10 to the 5 steps right to adjust it, don't we? Okay, so now let's look at 1,000. So 1,000, the decimal is here right now, but it needs to be over here. So 1, 2, 3, and we put 1. We moved 3 steps back, so we need to multiply by 10 to the third power. And these are exactly the same, they're just in different forms. We're never changing our numbers. We're not doing anything when we're putting it in scientific notation, because if we have to move it 2 places to the right here, we're moving this one 2 places to the left to compensate. So the big thing about scientific notation is that every scientific number is exactly representing the original number, the standard form number. They're exactly the same. Okay, the last one, all right, we have a decimal here, and it needs to be over here behind the 9. So 1, 2, 3, 4, 5 places. Okay, so now we have 9 times 10. Is it going to be positive 5 or negative 5? We moved it 5 to the right. So now to undo that, we have to move this 5 to the left. Okay, so we have all 4 of them in scientific notation first. Okay, so now I need to get another board, don't I? Okay, so I just erased the top part of the board. So here we have on the top, 6 times 3 is 18. Now 18 is not the right thing to have in the front of a scientific notation. We'll take care of it later. 18, and then 10 to the third times 10 to the fifth. We add those 2 exponents together and get times 10 to the 8th. Now, we put these 2 together with multiplication. 1 times 9 is 9 times, and then 10 to the third times 10 to the negative 5th. We add the exponents. 3 plus a negative 5 is a negative 2. Okay, now look what we have. Isn't it going to be easier to go ahead and do this division now instead of waiting to get this one completely in scientific notation? I think so. We would get the same answer if we went ahead and made that a 1.8. But I can do 18 divided by 9 in my head. 18 divided by 9 is 2, isn't it? So my answer is going to be 2 times, and then 10 to the 8 divided by 10 to the 2. When I divide, I subtract. So what is 8 minus a negative 2? Well, I end up getting 10, don't I? So I'm going to have 10 to the 10 power. And I can't write it on my board because I'm all out of room. But 2 times 10 to the 10 power is already in scientific notation. So I have to make no adjustments. So in this case, it was a little bit faster if we did not adjust that to make it scientific notation. Because when we just left it 18, it divided easier. And then I was able to go straight to the scientific notation because 2 is in the right form, isn't it? So 2 times 10 to the 10 is the answer. So this was your work in its scientific notation form, and there is your answer. Okay, so here we have another example that has both multiplication and division in it. And we don't have our numbers in scientific notation, so that's the first thing we have to do. So here we have to move this decimal from here to here. So that's 1, 2, 3, 4 spaces we move to the right. Therefore, we need to take this one 4 more spaces to the left. That's a really tiny number. So let's do 7 times 10. 4 to the left on the number line from negative 23 would be negative 27. Okay, and then we've got 4,000 times 10 to the 6th. We're going to take the decimal here. We need to get it right behind the 4. We moved that 3 to the left. Therefore, we have to take this exponent 3 to the right. And we're going to wind up with 4 times 10. 6 plus 3 more is 9. And then we're dividing by this one, which has 0.00004. We need it to be 1, 2, 3, 4, 5. We need 5 steps to the right to get it to where it's 4 times. If we moved it 5 steps to the right, then our exponent on our 10 must move it 5 steps to the left. And then lastly, we have 7. We need this decimal 1, 2, 3, 4, 5, 6 places to the left. So that's going to be 7 times 10. Since I moved it 6 to the left, then this exponent needs to move it 6 to the right. Okay, so now I have 7 times 10 to the negative 27. That's a really, really, really small number. And 4 times 10 to the 9. And 4 times 10 to the negative 5. And 7 times 10 to the 6. Oh, well, now we're ready to divide. And look what they did for us. They had a 7 and a 7 and a 4 and a 4. So that's going to be really easy. I'm going to erase the top part of the board and then we will finish. Okay, so this one, we're going to go ahead and multiply them together so that we can follow the same procedure of across and then up and down. Okay, so 7 times 4 is 28 times 10 negative 27 plus a 9 is going to be a negative 18. And then we're going to put over. Now we're going to multiply these 28 times 10. Negative 5 plus 6 is 1. 10 to the 1. So here we go. Now let's finish up. 28 divided by 28. We could put it in scientific notation, but it's easy to just divide 28 by 28, isn't it? 28 divided by 28 is 1 times 10 to the negative 18 divided by 10 to the 1. We're going to subtract. Negative 18 minus 1 is negative 19. So it's 10 to the negative 19. And since our 1 is in between 1 and 9 inclusive means 1's included, then it's done. We are finished. And that was another example of multiplication and division. Now, would it have been wrong at all if we had started here and not done the 28, but just said, oh, well, I have a 7 and a 7 and a 4 and a 4? That would not have been wrong at all. That would have actually been kind of smart, right? So basically all of your other numbers go away and then you can start multiplying these and dividing these. That would have been fine. Okay, so the answer is 1. We just did it by getting the 28 and the 28. All right, so this is our last practice problem. We have 20 times 10 to the negative 45. 400 times 10 to the 20. Neither one of those are properly in scientific notation. And 100,000 and 0.0008 times 10 to the negative 5. We have to fix all of these, don't we? So let's start at the beginning. So we've got 20 has a decimal here. We need to move the decimal here. That's 1 to the left, meaning that this has to go 1 to the right. So this is now going to be 2.0008 0.0 times, or just 2, times 10 to the, since that was negative 45, and we are now going to move it 1 to the right to compensate for the 1 to the left. Negative 45 and 1 to the right would be negative 44. So it's 10 to the negative 44. So that's our first one. The 400 has a decimal here. The decimal has to be moved 2 places to the left. Since I moved that one 2 to the left, this one needs to be moved 2 to the right, and we will get 4 times 10, 2 to the right, 22. Okay? So now, down here, we have our decimal here. It has to move 1, 2, 3, 4, 5 places to get there. So that's a 1 times 10. Since I moved it 5 to the left, this one has to move it 5 to the right. Okay, and then this one is very small. It needs to move to the right to get right there. So 1, 2, 3, 4 steps to the right, meaning this one needs to come 4 steps to the left. Negative 5, that's going to be a negative 4 added to the negative 5 is a negative 9. So we know we have a 10 to the negative 9. And then this becomes an 8. So now we have our new problem in scientific notation. So let's look at this and say, okay, we have everything in scientific notation. We can multiply all of this together. 2 times 4 is 8. We also see that there's an 8 down here. There is no reason why you can't cancel. 2 times 4 is 8. And there's an 8. So all of these turn into 1s, don't they? So I can basically just go to my exponents here. So it's 1 times, because all of those turn into 1. All right, let's put these two together. And we're going to get negative 44 plus 22 is negative 22. So negative 22, I'll just do my math here. And then these two, when I put these two together, I get 5 minus 9 is a negative 4. Okay, so the bottom is a negative 4 and the top is a negative 22, but don't I subtract them? Negative 22 minus a negative 4. So the minus minus gets treated like a plus. Negative 22 plus 4 is negative 18. So 10 to the negative 18. What a very, very, very tiny number. Okay, so that is your last example. And now we're going to start the practice problems. Here is your first practice problem. So I want you to copy it down, and then I want you to pause your video and see if you can do it on your own. Remember, the first step is to put each one of these into scientific notation. I hope you paused your video. All right, so this one's not in scientific yet. This one's not. This one's not. We've got to do all of them. Okay, so we take the decimal from where it is now to where it needs to be. So 1, 2 steps to the right means that this one has to move 2 steps to the left. Well, 2 take away 2 is 0. So we're going to have 10 to the 0 times 7. Now we know 10 to the 0 is just 1. But if you want to leave it there just so that you have all of your exponents accounted for, that's fine. All right, so then we have a decimal here at the end. 1, 2, 3, 4, 5 steps to the left. So 8 times 10, we need to move this exponent 5 steps to the right to take care of the 5 steps to the left we already made. 10,000 has a decimal at the end. 1, 2, 3, 4. 1 times 10, that was 4 to the left, so this is 4 to the right. Remember, our number should never change. It's just the form that's changing. Okay, here's my decimal, but I want it way over here after my number. So 1, 2, 3, 4, 5, 6, 7. 7 to the right. That was a really tiny number, right? 7 to the right means I have to compensate with 7 to the left. And then we'll put times the 4 because that's what's left over there. Now we look at them all, we say, yes, all of them look like they are in good scientific form. Now I could go ahead and multiply 7 times 8, or it's okay if I cancel the 8 and the 4. Why not? Okay, so 7 times 2 is 14, and on the bottom I just have ones now. So 14, which is not in scientific notation, we're going to have to slide it later, times, all right, so now these are going to add together because they're multiplying. So that's 10 to the 5, and on the bottom they're multiplying because they're multiplied together. So that's a 10 to the negative 3 on the bottom. So a 10 to the 5 divided by a 10 to the negative 3 is minus a negative 3. So this is my exponent work here. I took the 5 from the top and the negative 3 from the bottom, and I subtracted them. 5 plus 3 is 8. So this is going to wind up being 10 to the 8. Okay? And that makes good sense. Now, we're not quite done. But I just want you to think, anytime you get confused, remember 10 to the negative 7, if you brought it up here, would be 10 to the positive 7. So then that would be 12, and a 4 down there is downstairs. So 12 minus 4 would be 8. So you can check your work that way. All right, so this is the problem right here. 14 is bigger than 9. So my decimal is here. I want it to be there. So I'm moving it 1 to the left to get 1.4 times, and then I have to multiply this one 1 to the right, so 10 to the 9. So you should have gotten, let's see if I can make that bigger, 1.4 times 10 to the 9. And that is your first practice problem, and there are only 2 practice problems, so we are almost done. Okay, here's our last problem. It's a practice problem, so copy it down and pause your video. Go do it by yourself. All right, so we know that this one needs to be here. So we're going to move it 2 to the right and put a 4 down here. But since we moved it 2 to the right, this one needs to go 2 to the left. So 10 to the negative 11. Okay, here's my decimal, but it needs to be right after the 5. So 1 to the left, 1 to the right. 5 times 10 to the 17. You get really fast at this after a while. Okay, so here's my decimal, but it needs to be right there. 1, 2, 3, 4, 5, 6. I moved 6 to the right. That means this one needs to go 6 to the left. And a 4 goes right here. And this is a big number, so I have to take the decimal and move left. 1, 2, 3, 4. I moved left 4, so my exponent needs to take it right 4, and I put the 5 right there. So I have everything in scientific notation. What do you notice? Fun. Do you see a 4 and a 4 and a 5 and a 5 that will cancel? Why bother multiplying them together if you know they're going to all cancel to a 1? Okay, so 1 times. Now all I have to do is multiply my 10s together. I multiply, I add my exponents. 10 to the negative 11 times 10 to the 17 is 10 to the 6th. So on the top, everything becomes a 10 to the 6th. So we'll just put our little summary over there, 10 to the 6th. 10 to the negative 6, 10 to the 4. I'm adding those two because these are multiplied together. I get a 10 to the negative 2. So now I'm going to divide, which means I'm going to subtract my exponents. And 6 minus a negative 2 is 8. So times 10 to the 8. And we are done with our last problem on lesson 80. 80 should be a milestone. Okay, I think that's about 2/3 of the way through the book. So we're getting closer. And this is Mrs. A, and may God bless your day.